In today's video, let us see how to do algebraic factorization. More specifically, factorizing a quadratic polynomial. Polynomial, we know, is an expression with many terms. Poly means many. Polynomials can be monomial, binomial, trinomial, and so on. As you can see, monomial is just a single expression. Binomial consists of two expressions. Trinomial is when we have three terms in an expression. So, today let us see how to factorize a quadratic equation. As you can see, normally the word quad is associated with 4, but in algebra, quadratic is degree 2. Degree is the power of the variable in the equation. So a linear equation means it's an equation of a line. The degree is 1. Quadratic is 2. A typical quadratic looks like this. Ax squared plus bx plus c. When we have to factorize it, it means this quadratic has two linear factors. It will come in the form of two linear factors. X plus something into x plus something else. Let us see how quadratic factorization can be done by splitting the middle term. This is the most common method used, which is also called product sum method. In this method, the product is the coefficient of the squared term and the constant term AC here. The sum will be the coefficient of the middle term, which is B here. Let us see how we can do this with specific examples. I am taking a simple example. Square plus 3x plus 2. If you see, initially I am making the x square coefficient 1 for ease. After we understand the nuances and get comfortable with this, we can do sums or problems having coefficient of x squared something other than 1. So first step, let us identify what the product and what the sum is for this particular problem. Here the product will be 1 into 2, which is 2. The sum is the coefficient of the middle term 3. Our job now is to identify two integers that multiply to 2 and sum to 3. Which means you'll have to start listing the factors of the number that is the product here. Since it's 2, the job is pretty easy. For 2, 2 and 1 are the only integers. 2 into 1 is 2. 2 plus 1 gives 3. So now we are getting into the core of the process, splitting the middle term. So x squared plus 3x. 3x is the middle term. I am going to split it into the two integers we identified. X squared plus 2x plus x plus 2. So instead of 2, I am going to put this and this. Now the whole idea of this method was, since I could not take anything common in these three, I split it and got 4 terms. I can take something common in the first 2 terms and something else common in the last 2 terms, and that particular thing will be common throughout. In the first 2 terms, x squared and 2x, I take an x out. That leaves me with x plus 2. Now the idea of this method is that the same x plus 2 should come there. This is the beauty of the method. Now, The first two terms are done. On top I have x plus 2. In the bracket also I have x plus 2. So what into x plus 2 must give me x plus 2? Only a plus 1. Now you see that x plus 2 is common in the first as well as second term. Taking out x plus 2 common, what is in the bracket becomes one factor. What is outside the bracket becomes the other factor. So this can be given as x plus 2 into x plus 1. If the same were extended by saying solve x squared plus 3x plus 2 equal to 0, it's the same step that we do till now. We factorize using product sum and get this. But just that the sum doesn't stop here, you equate it to 0. If the product of two terms is 0, we know one of them has to be a 0. Which means either x plus 2 is 0 or x plus 1 is 0. Obviously, x plus 2 implies x is minus 2. This implies x is minus 1. So, x equal to minus 2 or minus 1 will be the solutions. This is how a factorization sum can be extended to solve. Let us see different cases of these. What I did here was the first case where we got a positive product and a positive sum. So, case 1, what we did earlier was positive product, positive sum. Case 2, the product still remains positive, the sum becomes negative, or rather it's a negative sum. The difference is the next case. So now let us see an example. X squared minus 13x plus 36. First step, identify the product. Plus 36, sum minus 13. Here the job is fairly simple. Since the product is positive, it means the involved integers both must be negative. Only a negative and a negative will give positive. So we still try to figure out all factors of 36. 1 36, 2 18, 3 12, 4 9, 6 6. When we've reached a factor that we've already written, it means we have exhausted all the pairs. Of these, check which of them add to a 13. Obviously, it is this. Since the sum is negative here, both the involved integers must be negative. We go ahead and split minus 13 as minus 4x, minus 9x plus 36. Now, same way, take something common in the first two terms. The same thing should come common here. What into an x minus 4 will give minus 9x plus 36? Something into x is minus 9x, that ought to be minus 9. Check for the next last term. Minus 9 into minus 4 is plus 36. Finally, x minus 4 one factor, x minus 9 other factor. So this was case 2. Case 3. Is a negative product. A negative product can have a positive or a negative sum, because partly the procedure is same. The final sum, the sign of the sum decides the integers involved. I'll give you an example. X squared minus 3x minus 28. Here, the product is a minus 28. The sum is a minus 3. Or rather, it's a difference here. Earlier, I didn't call it difference because the product was still positive. When both the involved integers are negative, you still call it addition, but the integers are negative, so the resultant is negative. But when one integer is positive and other is negative, the result is always Subtraction. Subtraction is the operation and the sign of the result depends on the sign of the bigger number. Now here, start listing the factors of 28. 1, 28, 2, 14, 3 doesn't go, 4, 7, 5, 6 doesn't go, 7 is already listed, so we can stop. Since it's a negative and the product was also negative, it means we'll have to subtract the two numbers. Which of these numbers gives a difference of 3? It's clearly this. 7 and 4 gives a difference of 3. Now, since the difference or the sum is minus, it means the bigger integer ought to be minus and 4 is positive. Now we will move ahead and split minus 3x as minus 7x plus 4x minus 28. Taking out x common. What into x will give 4x? Plus 4. So x minus 7 and x plus 4 would be the final factorization for this case. Case 4, which is a subdivision of this. The same example I am showing you. X squared plus 3x minus 28. You see the only change was that 3 was negative here, 3 is positive. So, still the two identified combination will be 4, 7, but just that here, since the difference is positive, 7 will be positive and 4 will be negative. You will choose to split it this way. So what into x gives a minus 4x, so minus 4. Minus 4 into minus plus 7, minus 28. So we see how the signs of the factors change here. That depends on the sign of the sum and the product in question. Hope that was clear. This is a very common factorization method introduced in grade 8 and goes all the way up to grade 12. You use it as smaller steps of bigger problems too. So hope that helps. I will see you in another video. Thank you.